Hi everyone, Austin with Sun Fun Kits. So today we're going to be doing a V4 build. And in today's build, we'll be using the REPT 280 cells that we should be carrying soon. They're about 45 days out. So you can, we have a few of them available to V4, but the major supply is going to be coming in sometime mid-December 2020. But as far as the build is concerned, we're just going to go over basically what you get in the basic package and some of the tools that you're going to basically need. So in here, you can see we have the V4 case, we have our cells, we have the SFK 200 BMS, the active balancer and mounting tray, main plate, some hardware, bus bars with nylon lock nuts. And for the hardware that you'll also, the crimped wires that have already been sized and cut to the right set with the proper lugs. For the tools that you will need to assemble, you'll definitely need some isopropyl alcohol, 90%. You'll need some crimpers and some wire strippers, paper towels, some sort of hand tool to tighten it, as well as Kapton tape, and extremely important, a multimeter or voltmeter to make sure that your connections are done correctly. So with that out the way, we'll go ahead and begin. And before we begin, we're just going to go a little overview of the major differences between the V4 and the V3. And we'll also show you the lid and just kind of explain what those changes are. All right, so let's go over what the differences between the V3 or 3.5 and the V4 bottom case is. So one of the major differences between the V4 and the V3 is that our previous V3 and V3.5 had aluminum side brackets that basically added a support mechanism for the main plate that kept your cells in place. And this worked very well. It was quite strong, and people have had many years of success with it, no issues. But it did require us to rivet two things on the side to keep this sort of plate in place. We also had two rivet nuts per side, so 4 nuts total, and it uses a 5mm to sort of keep everything in place. And the plate basically accommodated both sidewall heaters as well as in-between cell heaters. Works great, and when we did the 3.5, we increased the space, so now you could also have cell separators in place. So the evolution of that is now the V4. Let's move this to the side. So in V4, we no longer have those aluminum sides. And instead, we now have ledges that are molded in the case itself. So what that allows us to do is, one, we have no more rivets on the side, so this is now completely seamless, which will probably increase the water resistance factor a bit. And the other thing is we've moved away from 5mm bolts to sort of 7 4mm bolts. And we find this has worked well. There's really no reason to have that many bolts. The cells are already kept in place with the foam supports. So this also has a few ledges on the side that add support to it. So it's plenty strong enough, and it just makes the assembly a little faster for us, makes our production a little quicker. Another thing we'd like to show is in the V3 and 3.5, we increase the lip. So this tongue and groove is now taller. So if we compare, you can see the tongue and groove is taller and it sits up lower. So this required us, it's almost equal, but you can see now you have additional space. Now, why is that important? If you are sealing your lid and you want to have like water sealed, you could now have a much more area for your adhesive to connect. We recommend basic removable silicone. It should be sufficient to provide very good water resistance, but the increased height of the tongue and groove in the V4 will allow you superior sealing capability. So that's a little bit about the difference between the V3 and V4. Oh, and yes, we shamelessly have started watermarking our cases, so they will now have the SFK insignia on them. All right, now that we have the foam in place, the next step is going to be for us to start installing our cells. Now in the V4 kits, you have two ways of installing your cells. One is using the sidewall heating method, which is basically pads that go on the opposite sides of the walls. The other method is to actually use in between cell heating. Now, you should only use this method if you have certified or grade A cells, because if your cells are swollen, that method is not going to work well. But in our case, we're using certified REPT 280 cells, so we can go ahead and use this method. All right, so the way it actually works is that it's very important you get the orientation of the cells right. With version 4, you have to follow these instructions exactly. Unlike 3 and 3.5, you don't have the luxury of switching sides. So this must be done exactly the way it's shown. So the first cell that we will have its negative terminal facing downward and positive terminal facing upward. Now, just be aware, for whatever reason, prismatic cells, the black is actually positive and the negative is like cream color. I don't know why they do it this way, but this is how they do it for all the cells, so just roll with it, and that's what we're going to have to do. Now, to attach this, what we did was we took the heating pad, aligned it to the top, and we held it in place by using Kapton tape. So you can see the Kapton tape wraps around the cell and goes this way, and this is what keeps it in there, and we put 3 bands of it. This is 2-inch Kapton tape, and it keeps the thing in very nicely. It's extremely important to use Kapton tape or PET-based tape because it needs to be able to handle the heat. Do not use standard packaging tape or Scotch tape. It will melt. It may stay on there, but it's not a good strategy, and you should really use the Kapton tape. Eventually, in the next batch of these, we'll actually have adhesive on the back side, so this won't be an issue at that point. But for this, you want to go ahead and wrap it around using the Kapton tape. Okay, so now we'll start installing the cells. All right, so we got this first cell in. Now we're going to get the last cell in, and that's the way we want to do it. We want to install the cell in the very left, and then the cell in the very right, and then the cell in the very left. And notice how it's marked, the pad is on this side. See how it's positive and negative, and the pad is this side, but this is negative and positive, and this on this side. So make sure you attach the cell the right way. You're going to have your final negative here, and you're going to have your final positive here. So now we'll go ahead and put this one in as well. Okay, so that's how it's supposed to look. Final negative here, final positive here. Make sure you understand, black on the left, negative on the right. And now we can start putting the inner cells in. All right, so with V4 and actually V3.5 kits, we added these spacer options, which are 1 millimeter and 1.5. Now, normally when you have the sidewall heating, you would use either 3 of these or 3 of these, okay? But when you're using the in-between cell emitting, you can only have 1 or 1 of these, and you can basically attach it to the cell the same way as we did the heating pads, and that's what sort of keeps it in place. Now, to do this, you have to decide between 1 millimeter and 1.5. We like 1.5 because that's a little more stress, but for most of our customers, they've had a little bit of difficulty. So we are now saying just use the 1. It's going to provide plenty of sort of, stoutness or compression to keep the things in place, and it works just fine. So this is going to be the second cell. Since the first one's negative, this one's going to be positive. We're going to go ahead and attach this thing this way and secure it with the Kapton tape and install this third cell next. All right, so we went ahead and installed it. Now, one thing to go over. You'll notice the smooth side is facing out and the rough side is facing in. In our spacers, there is a sort of a rough texture side and a smooth side. So when installing the plate, the spacer onto your cell, make sure the smooth side is facing outward and the texture side is facing the cell. That's going to keep this thing gripped in place, but it also allows a smooth space for the last cell to come in. And you secure it the same way, do the heating pads, get it lined up as close as you can. It doesn't have to be perfect, but the closer it is, the better off you will be. And when that's in their place, we'll go ahead and install this third one. All right, so you can see cell number 3 is in place. Now notice, negative, positive, empty, and positive again. So this is going to be the negative one more time. So the last cell will be here. Now this cell people tend to have a little bit of trouble with. It's really not that hard. I will show you a trick to sort of get it in, but you want that stoutness. You sort of want it to be a little resistive, so that the cells don't move around. It's very important you do it this way. It's what has made us to where we have had no issues with cells coming loose, and you don't have to permanently glue your cells in place, so you still retain that serviceability. All right, so the method I like to use is to sort of put my hand in here, ball it up, turn it into a fist, and just sort of kind of twist it to the side. And then it's a little difficult because I'm holding the camera, but then it sort of compresses the foam. You can see when I do it this way, you see how I sort of compress that foam in place? That's going to give you enough space to slip that cell in. And as you slip that cell in, you just basically take your hand out and work that cell in. So we're going to do that next. So now that we have the cell positioned in, we're just going to rock it back and forth and put it on in. All right, so that last cell is in, and as you can see, they're nice and flush and even. And there's still a little bit of gap in here, and that's why if you did want to go to the 1.5, you can. It'll just sort of close that gap in a little more. But the V4, it's actually a little shorter than the V3.5. So if you're having problems, you could potentially even sand down your foam. I don't think you'll need to do that. I think this should be sufficient. Once it's in there, I promise you the cells are not coming out. As a matter of fact, if for whatever reason you do mess up, we include this little cell puller thing here, which if you mess up, you're going to go in, put it on here, put two little bolts on this thing, okay? Two little M6 bolts. Tighten this down and then use this to pull the cell out, because that's really the only way you're going to be able to get this cell out. If you don't do it, your cells aren't coming out. That's how it's. You can turn this thing upside down, the cells won't come out. So if you did get the orientation incorrect, if it's not negative, positive, negative, positive, you'll need to use this little puller to pull the cell out. And we're including this in all V4 kits, so you should have it. That's only if you mess up, then you do it. But once inserted, it's a very nice tight fit. You'll really like it. It'll keep your cells in place. And once that's done, we can start doing the wiring. Now it's time to install your main mounting plate. And just like V3, we will go ahead and do that. But there is a slight difference. As you can see, the REPT is a little taller than the ledge where the V4 is. So to get it right, we have to use these little shims to sort of get the height of it right. So it's very easy to install. Simply take the shim with the 4-side hole, put it in this way. If you notice, it's notched on the edges, so that's going to go towards the edge of the case. So you put your 4 right there, and your 3 hole goes right here. So this way you can't really mess up, because one side has 4 mounting holes, the other side has 3. Really no other reason except for the fact that this makes sure that you can't mount the tray in on the wrong way. So when that is placed, we'll now insert this. We're going to thread the wires for the heating pads inside it, get this mounted, and then put the bolts on. All right, so we got the plate mounted, got these things threaded through, and whoop, I have it the wrong way. So let me flip it around. Now it's correct. As you can see, the 4 side goes to 4, the 3 side goes to 3, and these are flipped in, and these will make it easier for us to install. So now we're just going to put the 4 M4 countersunk bolts in here to secure the plate on top. And with that being said, we will then start putting the bus bars in and start getting this thing ready. Okay, normally I would tell you to use hand screws, but if you have a power tool, you just be careful with it. So it'll take 7 of the M4 countersunk bolts, so just kind of put it in. And that should be enough to keep the plate in place. And I will tell you, your cells are not moving. They're locked in place. They're gonna stay put. This is probably the best system that does not have that's not permanently glued to hold your cells in place. When you assemble this kit, you will agree that this is just awesome. So you can try to move it around, it's not going anywhere, and the V4 is even better. We have thickened this up, so the rails in the V4 are about 1.8 millimeters thicker than the previous one, so it's got even more rigidity and even more stoutness, and that's just what's going to keep everything sort of in place. So the next step is going to be to install our bus bars, get our wiring done, and this is very important. Make sure you clean everything down, so that's what we're going to start doing next. All right, next you're going to take your isopropyl alcohol. We like 91%. You can get this from pretty much any basic store, Walmart, Target, Home Depot. And you want to just wipe down your terminals. Now, the good thing about the REPT 280 is that the terminal, the bus bar size for the terminal is a lot larger. I don't think you'll have a problem with even the 304s, but for this, since the terminals come in stock squared, it has made our jobs a little easier so that we can ensure pushing 300 amps, 280 amps continuous is not going to be a problem. So these are aluminum bases with a steel bolt press fitted and then laser welded in place. It is not moving anywhere. You're going to have really nice time putting it together. It's very easy to build, won't strip. So just make sure you clean all this contact off and do this. Now, we're going to go over, start doing the wiring, but we're going to clean the terminals of the wires as well to make sure we have a very good contact. All right, so here are our terminal wires and stuff like that. So make sure all these are nice and clean. You want to wipe down all these terminals really nice and clean. And once that's there, we'll then go ahead and begin installing them. You also have some washers in your hardware bag. You want to wipe the washers down with this as well. You just want to make sure there's no grease or any sort of residue when installing this. And that's going to make sure you have good electrical contacts so your readings are accurate. It's very important your readings are accurate, because if you've got incorrect readings, your BMS and stuff is not going to work correctly. So absolutely important that you wipe everything down with isopropyl alcohol before you begin installing the wires. All right, so we've got the bus bars just kind of set, and you'll see the final negative does not have anything. The final positive does not have anything. So make sure you wipe down the bus bars with isopropyl alcohol and paper towels. Get them lined up. You don't need to screw them in. You just want to position them so you have an idea what's going on. And before we begin, we now need to sort of get our heating pads ready. So what we're going to do is we're going to take 2 wires from one pad and join them together. And then we'll take the other 2 wires from each pad and join them together. You want to have 2 separate wires from each pad joined together. Do not combine the 2 wires together from the same pad. It's not going to work. So make sure you have 2 wires from either pad joined on both ends. And your V4 is going to include 4 terminals. You only need 2. We include an extra for you in case you mess up, but you only need 2. Notice one is for 6mm hole. The other one is for the 8mm hole. So that's going to be important. You're going to have one crimped with the 6mm hole and another one crimped with the 8mm. So for that, you're going to need a crimping tool. And this is only needed if you're doing the in-between cell heater. But I think it's a worthwhile investment. If you're going to be messing around with batteries and doing kits, having a nice crimper is a pretty nice thing to have. So we'll go ahead and crimp these on. So the way I crimped them is I took the wires, I twisted them together to sort of make one, and now I'm going to put that one of the terminals or lugs on there and crimp them in place. All right, so you can see we've got the yellow one crimped on, and we've got the black one crimped on. So now just kind of tidy it up. I'm going to use some of these little Velcro strips that I cut up into small little loops and just kind of tidy it up so that's wrapped. And then we're going to go ahead and begin with the main BMS and active balancer wires. All right, so now we've got our blue wire and red wire just kind of roughly put it in place. You'll want to see that there's a flat portion and there's a vertical portion. So the one that's vertically mounted, that's going to go towards the BMS. The one that's flat is what's going to go to your terminal. Then we put washers on top of the bus bars. And the reason we did that is because normally there's a little bit of a gap on the bus bar. So what that washer does, it just gives a little better base for our terminals to sort of mount in. And then finally, the red one is here. It's got an M8 terminal that's going to go towards the out. And you're just going to basically want to do it this way. And this is kind of the orientation you want to do it. So the next step we're going to be doing is we're going to start installing our BMS wire. In the first one, it's going to have the BMS black on the bottom, and then on the top, we're going to have the black wire for the active balancer also on there. So the final negative and the final positive, you actually share terminals. The rest of the terminals, you will be using a different post for one. Okay, after getting the main negative done, it's now time to install the BMS wires. So the way we're going to do this is we want you to follow these instructions pretty much precisely. First, make sure you wipe down your terminals with the isopropyl alcohol, make sure they're clean. And what you're going to do is you're going to start by putting the BMS wire, which is a thin wire, on to the positive of cell number 1. And then you're going to torque it down using one of the included nylon lock nuts. So that's how this one's going to go. All right, so the green for the active balancer is going to be the same, but it's going to go to the negative of cell 2. And that's how we're going to wire up all these. The positive terminals will have the BMS wire, and the negative terminals for all the cells will have the active balancer wire. And we found this produces the best results. The only posts that are shared are the final negative and the final positive. For all other terminals, you put the BMS wires on the negative terminals of cells, and you put the positive wire, the BMS wire, on the positive terminal of cells. So that's what we're going to do. Also, notice you'll want to consult the manual, but the way this is wired is all of your green terminals go to here, all of your yellow terminals go here, and all of your blue terminals will go here. And then both reds here and both reds here. So now we're going to go ahead and torque all these down. Just make sure you always wipe down all of these with isopropyl alcohol. It's very important. And that you torque these down. You want to get around 6 Newton meters for about whatever the equivalent is. I think it's like 45-ounce torque. But make sure they're in there snug. It's very important you get a good connection on there, because this is what you use to get readings for your cells. So now we're going to go ahead and torque everything down, and then we'll show you how it looks like once all the wires are installed. Also, one quick note while we're installing it. You'll notice that the terminal has a side that has some stamped numbers and one that's flat. When installing these, you want to make sure the side that has numbers is what is touching the bus bar flat like this, so that the shiny part should be above. Do not install it this way. Make sure you install it this way. That way it gives it a proper contact, and it is a proper orientation of the lug. So you can see here, you want the side that has where the crimp is sitting above. All right, so we'll finish this up, and then we'll get to the last red one and show you how the wires are set up. Finishing up, final wire. So you'll put the main lug, then the first lug will be the BMS wire, which is the thin wire. That will go on this way. And then the final wire, which is the active balancer wire, that is going to sit on top. Okay? So just make sure to do that. The BMS wire goes first on top of the lug, and then the final wire is the BMS wire. I'm sorry, the final wire is the active balancer wire, not the BMS. BMS wire first, then active balancer wire on top. All right, now that we have all the wires in place, now comes the most important part. We have to make sure all the voltages and all the wires are correct. This is critical. Do not skip this step. If you skip this step, you can blow up your BMS, ruin your battery, and then you won't be very happy. So make sure you follow these instructions correctly. Consult the manual. But basically what we're going to do is we're going to be measuring the voltages across these pins using these probes, and make sure they start at 3.3. The next one should be 6.6. The third one will be about 9.9, and the final one will be around 13 point something. And you'll verify this with your voltmeter. Look at the instruction manual to make sure you understand the orientation. It's very simple. You basically start from the final black and move your way down, and the final voltages should be around 13 point something, and the first voltages will be around 3.3, and then, like I said, 6.6 in the middle and 9.9 for the third one. Once you verify your voltages, you can then go to the next step, which will be installing the active balancer, and we'll tidy up the wires a little bit, and then we'll go install the active balancer, and then really we just have the final BMS tray, and should be done about, I would say, the next 4 or 5 minutes. All right, so we have done a little bit of cable management. Very simple. We've taken some of our little bit of Velcro strips and just kind of wrapped it around. Now you'll notice that the wires are a little offset. They're a little, they have a little bit of, they're not in the center. And you want to do that because your active balancer is going to sit right here. So you want to have a little bit of area. These flaps will bend down, so that's not a problem. It should have plenty of space. But yeah, just using a little bit of cable, management makes the install really nice and neat and clean. Now you'll notice that the BMS wire is coming out on this side, and the active balancer wire is coming on this side. So when you're doing install, make sure you route them that way. And if you got a little bit of excess wire, just kind of loop it around itself, and just secure it with some cable ties. It's not going to go anywhere. It should be nice and clean, easy to work on. And if you ever need to get back in there, it's going to be super easy to work on. Now, the reason we do this is because we want to keep all the wires equal length. At one time, we were recommending shortening the wires, but that can throw off the BMS. And since lithium iron phosphate has a very, very tight, flat voltage curve, we want to keep everything as even as possible. So by keeping the wires the same, it's going to make sure we don't have any resistance issues or issues with the wire size. This makes it nice, easy, and neat and clean. And yeah, now we can go ahead and attach the active balancer and go attach the riser plate and then install that, and then go, just sort of keep going on, and we should be complete fairly soon. All right, so the active balancer is very easy to install. When you get your kit, so we've already mounted it, and it has a little bit of a gap for air to move around with, but uh, this is only really going to be used when you first set up your battery, and maybe every now and then when you're charging a battery. 99% of the time, it's pretty much not active. Unless you've got some really weird grade B cells, then this is going to be working a lot more. But what we find is it's more beneficial than not. We include in all of our kits, as well as our pre-made batteries. It takes the stress off balancing from the BMS. I know there's a little bit of controversy on this little piece of device, but here's what we have to say regarding it. We've sold almost 2,000 kits and pre-built batteries, and we have never had a failure with this if you install it correctly. It works really well, takes the stress off balancing off your BMS, which is a much more expensive piece of kit. If anything goes wrong, it's very easy to replace. Have not had an issue with it. It's cheap. It works. If you want to, you can decide not to install this, but it won't be up to spec. I recommend you do it on there because we do it on all of our batteries, even our pre-builds, and we have had the data to sort of back up our decision to that. So for this kit, we highly recommend it. Keep it on. You can keep it on plugged in the whole time. You've got big 300, 270, 300 amp hour cells. It's going to be fine. Okay, so very easy. Attach this way, and then once it's in there, we'll just flip the kit around and start flip the riser around and start bolting it in. So when you put it in, you'll see like a small amber light turning on, telling you that it's basically there. And this is going to be nice and handy when we first do our first charge. So, another benefit of this, you really, as long as your cells are halfway decent balance, this is going to basically allow you to skip the whole top balancing thing. So yeah, that's not really a thing anymore. Certified cells, they're within 2 or 3 amp hours within each other, and this thing just sort of smooths out any little bit of difference. So yeah, no need to top balance your cells when you have one of these. All right, so after inserting the lid, we're gonna flip it around and just secure the riser plate with 3 of these countersunk screws. Very easy. You don't need to go super crazy. Just go gently with the power driver, and once that's there, that should secure the plate. Do not install anything here. The top plate will actually keep this side in place. But now, yeah, that's, for the most part, the hard part is done. Now we're just going to go over to start putting the BMS and show you how that portion is done. All right, so now let's just actually briefly talk a little bit about the BMS mounting plate in version 4. So before we actually begin that, we'll show the mounting plate for basically version 2 to about version 3.5. And this is sort of how we've been mounting BMS plates. And it has worked fairly well. Not too many issues. People have been happy with it. It works great with the 150 and, basically around those ranges. But some of our customers that are basically running this at much higher spec, they're running like 170 amps for like an hour or 30 minutes. They are getting this a little hotter than we would like. Generally, that means they're getting their batteries at 100 in the 140 degree Fahrenheit range. Not something that we think you should be doing. I think those amp bursts, if you're needing that much power, get 2 batteries. They should only be used for like momentary, but since in the kits we don't restrict you in any way, you can run it as hard as you want. That is something that is, potentially of concern. So here's what we have done for version 4. In version 4, we've gone to a 1H, I think, 3mm fiberglass sheet. This, you can now run this thing 200 amps constantly. It is not going to have any effect at all. So as you can see, it's solid in the bottom, but we still kept room for venting holes so that the way that these spacers are, they can have airflow happen, but you now have a much more solid and much more heat resistant setup. The other thing was issue with these posts. Every now and then, a customer would call us that during shipping, one of these posts broke off. Now, in our test, we don't see that happening, but we've seen enough videos to where we said we got to resolve this. So now we're going to show you how the version 3 is set up, version 4 is set up, and which way the standoffs or the mounting posts for the lid work. All right, so here we go. As you can see, version 4 now has these aluminum standoffs that have these countersunk screws on the bottom that keep everything nice and installed. Now these will come pre-installed for you when you get your kit, but we wanted to kind of show you the differences between going from this to this. Now this should be much stronger. In order to snap this, you got to snap 3mm thick or 1/8 thick fiberglass. So if it broke, something really bad happened, I'd be kind of concerned. But that was really the only potential issues that we had with the design, and this one corrects it. If you have a version 3 or 3.5 and you do want to upgrade to this plate, we will have an option. This plate with the standoff is going to be about $25, and what that will do is it'll include the printed brackets, but it only will be available for the 200. If you have a 150, really no reason at all to do this. It is not a problem with the 150. 150 cannot get hot enough to really become an issue. It's only an issue with the 200. And if we didn't have the cover on and you had ventilation, airflowing, it's not really a problem with the 200 either. It's because we're in an enclosed environment and we're running high amps. Because of that, it is something that, you know, this fiberglass plate will sort of alleviate. Now, one thing to note before we install, there are 2 mounting holes in the bottom, on top, and 1, 2, 3 on the bottom. And the same thing corresponds this way. So make sure you understand how it goes. The ones with 3 holes is going to go towards the bottom side, and the one with 2 holes is going to go towards the top. And we'll install this BMS plate next. So you'll notice that in your kit, you've got some long screws and some short screws. The 2 long ones are going to go on the outer side on the bottom, and the other short ones are going to go basically be the 3 holes. So you want to take a few washers, put some washers on here, and then just basically mount the screws with 2 or 3 washers per screw, and that's going to keep everything in place. All right, now that we have our screws in place, they're not fully tight, they're a little loose, but what that basically does is gives us a little bit of sort of adjustment room. That's there in case when you put the lid on, everything is not, if it's not exactly right, you can kind of tweak the tray a little bit to get it just right. And we have to do that because the nature of injection molding, it's pretty close, but can be a little off. So you may need to tweak it ever so slightly to make sure the lid is on perfect. Okay. All right, now it's time to mount your temperature probes. The SFK 200 BMS comes with 2 temperature probes. You can mount them on the cells, you can mount them in the case. It's personal preference. I'm not going to get into the debate on where it should or shouldn't be. This generally just kind of gives you an overview of the temperature of inside your case. So whatever you feel is comfortable, just position it and secure it with a little bit of Kapton tape, and you should be good to go. So I just put one here, and then I put some Kapton tape to secure it in place. It's going to be good enough for me, but again, you can sort of put it wherever, and that will be entirely up to you. So now let's begin by installing these wires and showing you how that process works. All right, so I have the blue wire installed. What I did was I kind of looped it around here, came here, and notice how I have the lug is sort of inverted. And that's the way that I like doing it. You might be able to flip it around, but this has worked well. Just you want to make sure you have a nice torque. Don't torque this too much or you'll twist the actual brass connector, a copper connector. But just to make sure you have a nice snug fit. And you can measure current flowing with the infrared camera to make absolutely sure. And the wire for the V4 is intentionally long so that you can curl it around the way you want to, and it shouldn't interfere with the lid putting on, but you'll want to do that. Now, notice we did the same thing for that side. Notice how there's one lug that has an M6 hole and the other lug has an M8 hole. So the M6 hole is going to go here, and it's oriented vertically. And basically what's going to happen is you're going to position this wire so it sits on top of the red wire, sort of like this. And what that's going to do is going to give you plenty of room to mount the final lug, which is sort of going to go a little bit like this. Okay. Now, one thing to notice, we have not plugged in our BMS wire. That's going to be the very last thing we do after everything is installed. So do not install this until everything is set. Okay. All right. So next we'll sort of secure the heating wires and also just sort of put our BMS, our Bluetooth dongle, and then we'll start attaching the lid. And at the very end, we will then insert the BMS bouncing wire. All right, so we installed the black lug on the heating port of the BMS, and the yellow one's actually going to go onto the case lid. So that's actually going to be to the red, and still have not connected the BMS wire. So make sure you don't do that until the very end. So now we're going to start putting the case lid on and show you sort of the final overall process. All right, so in this kit, we're going to be using our black lid. So it's going to be black on black. And before we install, there's a thing that we want to go over. So during the injection molding process, you may see that there's some little blemishes and residual ABS material on these lugs. We want to sand that off so that we have a smooth and flush and debris-free area. So what you want to do is just take a small piece of sandpaper, like, 300 to 400 grits, all you need, and you want to sand that down to where it's perfectly free of any residual material. Then you want to wipe it clean with isopropyl alcohol, and once it's done, you can then install your mounting bolts and get the lid securely installed on your battery. All right, so we just finished sanding these down and then wiping it down with some isopropyl alcohol, and as you can see, the color has kind of changed, but we've removed all that residual ABS that was on here. So now you will have a nice clean surface for your lugs to mount. So we're going to start off with the red lug first. So the way it is mounted, you can see we have the bolt going, but before that we have the yellow lug for the heating pads on top of the bolt, and then we have the main red lug, and it's going there. Now, I like to use a little bit of Loctite, the very last thread of this, just to kind of keep it in place. You have to be careful. You don't want it traveling down to your lugs, but that's just personal preference. If you don't feel comfortable, you don't need to do it. It's just, for me, I have a habit of doing it, and I'm very careful when I'm installing it, so I make sure that nothing will go to the lug. So I do it just for personal preference. Another thing you could do is after the lug is installed, you can cover the whole section up with silicone. So there's just various ways to secure your lugs. Whatever you feel comfortable with, you can do that to secure it. But now we're going to go ahead and start putting the lid on. All right, so we just put the red lug on, and we just sort of tilted the side using a powered screwdriver. We were able to get that in there, and that's the way you will mount this in there. You'll just sort of go in there and make sure it's tightened up. And once that's done, we will then move on to sort of the black wire. Now, this can be a little tricky for some folks. So let me just show you the orientation it's going to eventually be. You take your black wire, you go over this, and it will sort of loop around and be in this sort of fashion right here. Okay. And we did it that way so that you have maximum room to work on it if you ever need to take your lid off and do it. Now, this was not my first choice, but based on feedback, people said, it's a little difficult if you ever need to get in. So we've extended the wires, but by doing it that way, you do have to install it in a certain way. Once you get it right, it wires real clear. If you don't have it routed correctly, you may have a little bit of difficulty on there. So we'll just sort of show you how it's going to be all said and done. And once that's there, you'll see that it works very well. So now we're going to go ahead and just mount the black wire. All right, so the black wire is installed. Now, if you want, you can put some silicone on top of this to sort of keep it from, coming loose or vibration, whatever your preference is. Not really needed. I like to put, like I said, a very little tiny drop of Loctite in the last thread, and that just kind of, it's red Loctite, so it's a little stronger, so that just sort of keeps it in place. But you can certainly put silicone on there if you wanted to have it like to where it has more anti-vibration. Again, notice how the yellow lug of the heating pad sits on top. So it's very important. You do not want this on the bottom. If you do, you're going to have bad pore contact. It will overheat. It will damage your battery. Absolutely critical. Lug on the bottom, yellow lug on top of the main lug, and then bolt it down with the M8 bolt. All right. Now you can secure your Bluetooth here. You can put some Kapton, or you can put some double-sided sticky tape. I tend to just kind of let it chill out. It's not going anywhere, but certainly you can mount it whatever you want to. So this makes a nice place. But finally, we can now attach our BMS wire. So that's why we want you to do this at the very end, because if it's attached before, you could have live wires and it could spark. It's not a good time. If you do it towards the end, everything's nicely in place. If you want, you can check the voltages one other time just to be 100%, but we did check it before we installed it, so I think we're gonna be good. And I think we can install this here. And yeah, we can see the Bluetooth light just lit up and it slid in just fine. And then we can just kind of nicely tuck this in place, use some of the zip tie, some of those Velcro ties to kind of wrap this in place. And then we'll just show you how the wires look when the final is, and then, you know, we'll start buttoning up the lid. One thing before we do, one thing I want you to notice how the lugs are almost perpendicular to the top of the lid. That's the orientation you want to have the lug. If it's sort of twisted a little bit, you may have a little bit of difficulty. And if you're installing it, it's not quite fit, you may need to tweak it ever so slightly to where it's perfectly mounted. So just sort of keep that in mind. And I went ahead and, you know, go ahead and attach that with some Kapton tape, so now it shouldn't move. But yeah, we should now have the lid closed up, and we'll show you how that looks like in a second. All right, so now we have the lids on, and you can see the aluminum standoffs are pretty darn close, and they may be a little off, but that's why we said if you needed to, you can kind of wiggle that. That should work. But now we can go ahead and close the lid up, and we'll be using, the V4 uses slightly smaller screws, so we'll use these 4 screws to kind of keep it in place. Now, if you wanted to seal your battery, you can now put some silicone around it. It is a tongue and groove structure, so you can seal it. I normally don't mess with that, but if people wanted to, this is where you would put it all around, put it on the perimeter, and as you squish down the lid, it will sort of keep a nice tight seal. All right, so the last step in the build is to put your rope and handles. It's very easy. Just slide one of the barrels in here, and then you're gonna insert it through these holes here. And once it's in there, you'll just use a flathead screwdriver to notch them into place. And I'll show you that in a second. Other side. And this should be plenty to keep your battery, give you nice little handles to work with your battery. All right, so the handles are there, and now we'll show you how to do that. Now, just to let you know, if these are removable, so it's not permanent. Some of our customers actually don't use these handles. They actually use these things as anchoring points to secure the battery permanently. So you can do that as well. Whichever method you prefer will work. It's very easy. These have like a little latch. You can almost put it in with your hand, but to secure it, you'll need the flathead screwdriver. So they got a little notch. You see how they have a little recess in there? That actually slides into a notch underneath the thing, and that's what actually keeps the battery in place. So I've kind of just put it in there nicely with my hand, but I'm going to go in there and make sure they're secure with the flathead screwdriver, and that's going to give me a nice little handle to move these batteries around. So yeah, we'll go ahead and finish it off with the screwdriver, and I'll show that to you in a second. All right, so we have the flathead screwdriver, and we're just going to press up on that till we hear it click into place, and once it's there, the handles are secure, and you should be able to get ready to move them around. All right, this one's pretty much in, so yeah, that pretty much wraps it up. All right, so that basically concludes our kit build. Next video, we'll be doing a charge and discharge test. Just like the lugs inside the case, you may want to sand with 300 to 400 grit sandpaper, get this nice and clean with the isopropyl alcohol. In version 4 and above, we are not going to be doing any of the bolts. We're just going to go do the top mounted one. By far, this is what people with V3 and V3.5 wanted. I mean, it wasn't even close. Like, for every 100 orders, one person may want the bolts. So this is how we're going to go forward. They're nice heavy-duty M8 bolts with a nice hex head, so it's easy to mount. You want to check the perimeter of your case. Make sure it's fully sealed. Make sure you have no gaps around it. And, you know, that just is going to show you that everything is nice and tight. And once that is done, you should be, you should sort of be good to go. And then, yeah, it's off. Get charging, and then let's see what we come up with. And yeah, next video will basically show you the results, and we'll also do a capacity test to sort of see how these REPTs are performing in a real world situation. All right, well, thank you very much. All right, everyone. So this is going to be our sort of capacity test for the V4 battery using the REP2280. So let's just kind of go over the setup. So to begin, we also have this little shunt, which has currently been zeroed out, and it's going to sort of measure it. It has its own little leads, which I think act like V-Sense leads. It also has a supplementary power supply that keeps this running, so when the BMS shuts off, it will not shut off, and that's powered by this little 12-volt brick right here. And basically what that does is it sends power to the little shunt so they can keep running. We also have our app running, which basically is going to monitor everything, and all the cells are pretty much 3.59, so they're full. We also have the little GoPro that's going to try to take a time lapse. It may or may not work. Have not tried that before, so we'll see how that works. Our electronic load is going to be set to 55 amps, which is about what 0.2C is. So now we're going to go into the app, go into the benchmark mode, and we're going to set the test to begin, and then we're going to turn on the electronic load. So it says, oh, okay. So we'll go back to tools, and let's set the BMS cutoff to 10 volts so we can get our full. We'll update that, and then we'll begin the test. Alright, so we're going to scroll down to low voltage cutoff, set that to 10, then hit update. And you only really need to do that when you're doing a benchmark test. So now we can go back to benchmark. Okay, so now we're going to go ahead and hit begin test. I say it test started successfully. So, okay. So now that test started, we can go to our electronic load and basically hit enter to start the load. So now we're drawing 55 amps, and as you can see here, it's saying 54.8. So little bit of difference right off the bat. As you can see, the electronic load is saying 54.994. The internal BMS shunt is saying 54. Well, now it's saying 55.46, and this shunt is saying 53.3. So right now we're basically comparing three different measuring things, and you can already tell there's like a 1 to 2 amp hour difference. So we'll see how this sort of runs, and see what type of results we can come up with. But it'll be interesting. So the time-lapse video is running, so we'll see how this works, and once we get it closed, we should have a better idea of what's going on, and then we'll have the results posted so you guys can see it. Alright, thank you. looks like our test is finished, and that's what the app will say when the test is completed. As you can see, the electronic load is saying 0, so the BMS has gone to shut off. And let's sort of see what the amp, what the watt meter has said. It says about 3.64 kilowatts, and according to it, it says 284 amp hours. But that's probably at a slightly different voltage. So the first we're going to do is turn off this, and then let's go to our app. So say OK. Alright, so our app detected 285.6. So you can see there's a slight difference. This says 284, and our internal BMS shunt says 286, 285.6. And that is something that you guys will just, I mean, that's how things work. Not everything is going to be perfect. It's fairly close, but can be slightly different. So if we go to our Files tab, we now see that we have just completed that test. So we're going to upload these results, and we'll have a link to this on the description of the YouTube, so you can check it out as well. So we go ahead, upload, and it's going to start updating it, and then it's going to say go ahead and submit it successfully. Alright, so now if you want to see the details, you can click on View, which will take you to the SunFun Kits website. And anyone that has either our kit or pre-built batteries is able to do this. So anyone can do this. And now we can sort of see what we have. And I'm just going to briefly go over this. The details will sort of be, you can look at it. But it measured 12.84 nominal voltage. So 12.8 is what lithium iron phosphate batteries are measured at. So it's actually testing higher than a normal nominal voltage. And we can see that we tested to 285.65 at 12.8. But that is the equivalent of 286.58 if measured at the traditional nominal capacity, of a battery. And we were testing at an average of 54.9 amps, and our average watts was 704.98 or 705. The average BMS temperature was around about 96 degrees Fahrenheit and about 88 degrees Fahrenheit for the case. Starting voltage was 13.73 and ending voltage was 10.8. Now, we estimate on our 200s the BMS loss was about 84.37, and that's the 200 will use about that much. You're looking at 1 to 2% loss from using that BMS. The 150 will lose about 50 watts. So if we take into the account the losses from the BMS, our normalized capacity would be about 3.75 watt hours, and our normalized capacity in amp hours would be about 293.17. So then you can see the battery data. It'll sort of show you the voltage. You can see the temperatures, see how the temperatures were here, and if you want to see in Celsius, you can also switch that to Celsius and sort of see. You can also see the cell data. It'll tell you what each sort of cell kind of measured. And also, if you want, you can see a comparative graph of how all the cells are. And let's look at the voltage. So it's very good. If you look at this, the banding of the voltage is very good. So that's definitely reminiscent of grade A certified cells. They hold very close together. Same thing with cell watts. Very tightly grouped. Normally when you have a grade B battery, this is, you see much bigger banding. So yeah, we'll have a link to that, and that sort of concludes our V4 with REPT 280 cells. I think you guys will like it really well, especially some of the people that are not very happy with the 280 EVE 280Ks. I think this is going to be a fantastic alternative, and we have them available in our international warehouse, and they will be available in our U.S. warehouse by, I would say, mid-December. All right, thank you very much.